Earlier, I presented my project Biomimicry 3D printed soft seeds, but I didn't really talk about the software I used. And to model everything, I used Rhino. And here you can see how I built the model in Rhino. But what I wanted to accomplish was beyond the possibilities of Rhino, and I had to divide the model into slices because the file became too big. And my point is that the tools don't exist to create what I'm doing. So as designers, we need a new set of tools that allow us to design, and I think especially to create bio-inspired design. All the developments in technology force us to design in a different way. And because of 3D printing, we are able to use material in a totally different way, and we can use less material than we do now. And we can design in a more sustainable way. And until recently, we were accustomed to force a material into a desired shape. But I think the way of designing has changed, and now, instead of forcing a material, we want to generate and grow the ultimate structure or the ultimate shape, just like nature does. And it's a major shift from designing fixed shapes into designing the behavior of a product. And I think software should respond to these new possibilities. And for my first prototypes, I used laser sintering. But for the development of the project, I'm using a technique created by the Bartlett School of Architecture in London. And it's much faster and less energy intensive, and you can create large scale products. But more interesting about the Bartlett's is that they also developed a tool behind this technique. And this tool has a totally different approach than the conventional software. It fits the way designers and architects are designing nowadays. And the key to that is that you can apply forces to a model, and then the optimal structure will be generated. So you can load a solid model into the software, and then the software defines where the material should be. So I have a small movie. Here you can see an architectural object, and here you see the stress values that are placed on the model, and then the software voxelizes the shape and processes the behavior. And then after this, the software is defining the geometry of the path based on the loads that are placed on the model. And then it's possible to print this model out of filaments. And after this, we started to do a collaboration. And here you see the first simulation of the chair. But the software is built to create only rigid structures because it's built for architecture. And I think it's a very good first step, but we as designers are looking for, I am looking for a tool that's able to simulate not only stiffness, but also dynamic characteristics as well. So I think the challenge is, how do we design tools to accomplish of what designers are looking for? Thank you.